For our third example here, we've got some data about how long Andy spends on phone calls each month, and again we're being asked to find their standard deviation. This time we've been asked to estimate it, and we can see that we're dealing with grouped data, so we don't know the exact length of each call, so our estimate of a mean or of standard deviation is going to be an estimate. I'm going to use this formula here as in the second example, and once again we can adapt it for our purposes because we're working from a frequency table. So this time S squared is going to be, let's start with the mean value. To find the mean we're going to have to do frequency times the data value. Because it's group data we're going to have to use the midpoint, but either way it's going to be the sum of the frequency times the data value, and that's all over n. Total number of values is found by finding the sum of the frequency. That would give us the mean. To find the sum of the data value squared, again we're going to use the midpoint, but we're going to multiply that by the frequency. So that's going to be so n there is the sum of f. So we need to find out these values and sub them into the equation. So first of all, to do our product of frequency times x, we need the midpoint for each group. Then we're going to multiply the frequency times the midpoint, so that's f times x, and then we're going to also multiply the frequency times the data value squared, so the midpoint squared. So to get the first one is simply 4 times our 2.5, and then I'll put the values in for the rest. So I can find the sum of fx is equal to 285. For this column, f times x squared, so we're going to square the midpoint and then times by the frequency. So the frequency 4 times 2.5 squared, that's 6.25, and that gives us 25. So again, 15 times 7.5 squared, five times 12.5 squared, and so on. And so the sum of f times x squared is equal to that. So we found that. We need to find the sum of the frequencies. So that's the sum of these. And that's 27. So we can now sub these values in. So sum of fx squared, 6, 4, 7.5 divided by the sum of the frequencies. Let's take away sum of f of x is 285 all over the sum of the frequencies, and that's squared. And if we work that out, that gives us 128.858. So we found the variance now, we found s squared, we want the standard deviation s. So we'll simply square root the variance. And that gives us standard deviation of 11.35.